I was asked for a video going over some of the data processing and merging. So for the project. So let's start with I'll start with the bottom line up front here. Here's my pseudo project presentation. Yours can be much different from this. This is just what I suggested. That you have a slide with what you're about to present, a slide that shows sort of the basic behind the scenes. This is what we're going to do. You don't need to have a lot of words on it, but should be kind of clear what what the problem statement is that you created, right? And you can talk about what it is and when you give the presentation. Here I have put the and then this is not as clear as I would like it to be, but I put the synthesis, the graphical synthesis on top of that, where you can see where I've got the grounds and the driving dyad. And now you can see this is the SolidWorks working model for the thing. And then on the next slide, here is the adapted model for printing. And then here I have made the animation on top of it. And these don't always work great. You can see this one. Because I think this is because the computer I'm using, I'm going through a remote. I'm going through a VPN right now. Let's see if we can get this thing to work correctly. Oh, no. Yeah. I might need to recreate this video. I don't think it's actually the video that's getting messed up right here. It worked a moment ago. Yeah, it doesn't seem to be working correctly right now. Well, get that sorted out, please. Yeah. Anyway, so there's the animation. Here is the MATLAB output of the position analysis, including the coupler curve, and you notice that it coincides with the coupler curve that we had from SolidWorks. And then for the rest of this, our main goal is to compare the MATLAB and the SolidWorks. Here, and once again, the graphics are trying to catch up, I think, because I'm recording this remotely. Here's the velocity analysis from the MATLAB and from the SolidWorks, and I'll go over how I got these. I'll also show you another way to present them. I would, if I was going to take the time, and I probably should, I could superimpose these in Excel, like move them both into Excel and plot them together. Would have been a better way to get them to work, but I'm just screen grabbing and putting them up there. I note that I suspect you could note that the magnitudes have kind of flopped, right? So I think these might be rotating in the opposite direction. You'll see that we have just underneath 400 millimeters per second here in this, but you can see that we're right at 400 millimeters per second. But here at the bottom, it looks like we're right at negative 400 millimeters per second. And right here, we're somewhere like 320, right? So it looks like we might have a directional problem. Not quite sure. That's why it would be kind of better to be putting it in Excel. And here is acceleration again, or acceleration, and I'm making a comparison again. And we have pretty good correlation. You might note that in the SolidWorks down here, I made these scales to match because I can't really get rid of this. And of course, I could just export this to Excel, and then I may have a lot more control over what took place. But these general ideas, if you're going to make the comparison, make them so that you can that they're as similar as possible, right? Including the time is 6 seconds, the time is 6 seconds, what have you. All right, so here is the only I didn't get the force analysis done on my project, but for MATLAB, but I have it here for from exporting from SolidWorks. And now, so the rest of the video, I will show you how I did all of this, and maybe I'll make a parallel presentation here, similarly to show what I had done. And I guess I'll upload. I don't know. Maybe I will. I don't know. I can't decide. So let's go back to the, here is the project, right? So I have, you can adapt to this, you should adapt to this code for your own. I have my driving dyad dimensions as I put it through here. You can see here, so we have the A, B, C, and D on all those lengths for the crank, coupler, rocker, ground, and then here is the orientation ground angle, right? Because it's not, a lot of times for when we're just doing 4 bars, we make that 0, but in this case, but this case, it's actually at a slant. And then here's the rocker. So here's the rocker. So here's the main thing that's going back and forth. And yeah, so you can see what the initial angle of the coupler is going to be right there. That's and I numbered them different, consecutively. So the one in the driving dyad, which is Grashof, that has the typical variable designations, but here I have E, F, G, and H for the lengths. I just continued with the alphabet after D, and then also the numbering sequence. So theta 5 is the ground, right? And these are a couple knowns. Like this is where it starts, right? It just happens to be for my situation that's 0. Yours, all of your angles and so forth will have to be adapted to your situation. Here's also that coupler curve, right? So you want to have some point maybe that you want to follow that's on the coupler. So just to give a kind of a comparison, apples to apples with the SolidWorks. And I guess I don't need to run through this. This was an assignment, I believe, that you had to go through here and label all of these things to understand them. But we do a position analysis all the way through for the number of rotations, and notably, let's see, where did I get that from? Here's the input position. Where's the velocity? Do I do that later down? I guess I must. Yeah, I don't see where I put it'd be nice to put the velocity up above. But here's the angle that I'm going through, and this is for 2 rotations, right? So that's where you have 4 pi right there. If you wanted to have it, that's where, if you wanted to have more rotations. Notably, there's also a starting angle. So I go, right, 2 pi, 4 pi, excuse me, back to that angle. All right, this is going to be a great video. So anyway, I guess it isn't until I get down here somewhere. The rocker bar calculations begin here. All right. And yeah, I don't know where it is I did my the velocity. Gamma positions. Oh, there it is right there, omega. And of course, this is the crank velocity, 20 RPM of the driving dyad crank, right? So I had to be careful in this guy right here. I originally put the motor onto this pot, but we want to make it sure it's the same. So I put the motor actually onto your crank. So that's something that's important to look at. But yeah, okay, so we get that we also, I've created a timeline based on the position divided by the the position divided by the position divided by the angular velocity. So to create a time. So when I go down to do the velocity and acceleration afterwards, that's just going to be right here where we have the velocities. Just take the difference, use the diff, and numerically take the derivative of the position, and then numerically take the derivative of the velocity to get the acceleration. So we'll run this and get these graphs, right? So I had made these graphs. So here you go. Here is the coupler curve, and here is the position of the thing. So there's in the initial position, but it has the coupler curve built right there. So you could take these and stretch them. You could take these curves and stretch them, and then come over to edit, and then down to copy figure. Now there'll be a little bit, sometimes there'll be a little bit of a delay. It's like if you want to go paste something right after you did that, for whatever reason, it actually takes a little bit of time for it to get into the clipboard. So if you go paste something, you might get unexpectedly get a different figure than you had expected. So let me come down here, and I will do boom. I'm going to Control V, and here is our figure right in there. So similar to what I had just done. It does look like it's a little faded. You know, we might actually look at this and go, I can't read the numbers on that. So we're kind of lame, but maybe we'll have to trick it by making the thing a little smaller, like that, and then go Control copy figure. Like wait just a heartbeat there, okay. And now, yeah, that made it a little bigger. Made the numbers a little better. To read it just a little bit better. All right, so, and then also, maybe you want to do something similar with this, right? We want to try to make everything similar as possible. We always have two different choices, or you could actually have several, but one method we could do is we go to View, Display, no, I'm sorry. View, Screen Capture, Image Capture. All right, now the image is in your clipboard, and you can Control V, and you're right there. But there's some crap in here, stuff, not crap, stuff that we want to get rid of. What we should do, in case you weren't familiar, click on the image. Here's the conditional formatting thing. Let's see, I'm trying to move it over to the side. Right here, Picture Tools comes up. You can go over to Crop and go down and get rid of a bunch of things. Get rid of the blank spaces. And use up your thing, and then maybe you want to try to see what these things look like on top of each other. This is completely unnecessary, but what you can do here is we can highlight that and go to the color one where you see set transparent color. Go boom, right? So you didn't see anything change, but you could now. I just highlighted this and copied it. Control C, and now I paste it on top of this. Whoops, it didn't work. Let's see. Let's try that again here. There you go. And if I wanted to, I could attempt to stretch this out. And it's got a lock aspect ratio already defaulted on there. So it will work out there. But you could I could almost make these on top of each other. Right? But I gotta tell you, the little details when you're making a presentation report, that looks pretty good right there. So I will Control X, and maybe I'll get rid of him, delete him, and I'll go Control V. So when I go from this one to that one, I can kind of see that to make the comparison. It's the little tiny things that make a presentation and a report worthwhile. The attention to detail. All right, so let's start with the velocities, maybe. Yeah, I guess so. Now, I already have them done on here, but I can work through these again in case you need that too. Right. So let's make a results thing. We'll make graphs of results. My first result, I guess I already did the trace path onto the thing, so I should have probably showed that, but let's just do the velocity one. Where you got velocity. So I clicked on the little graph-looking things as results and plots. I'm going to go to displacement, and then the next tab down. I already did the trace path, so if you want to do the trace path, do that one. We'll go linear velocity, and then I'll say my x component first, and then I'm going to pick a little tiny point, like, oh, right there. I did it there. That was good. Okay. And I'm going to create a new plot. And if you'd like to already use you could do the show vector onto the thing, but of course, obviously, well, it's showing the acceleration one right now. That's because in this position it has no velocity. But you can put that on there, and we will get this result right here. And then you can do it again. And so we'll click down on that report thing again, and then come down for displacement velocity, and do linear velocity again. This time use the y component. We're going to have to move this and try to pick that again. Try to pick the same point. You might have to monkey around. Rotate the thing around with the trackball to be able to get the point selected again. We're going to add it to this existing plot, which is probably like plot 5. Yeah, it says plot 5. And boom. And then I'm sorry that the numbers are too small to see accurately right here. That's because I'm doing the remote thing, working from home, and this is actually working on my computer at the office. But it's kind of necessary each time to do this again, for whatever reason. Don't quite know. It has a little quirk that way. But we expand this last plot down here in the bottom left, and go to that one we just made. Right click, and then edit feature, and then just click green again. And you can't quite tell because the numbers are so small, but that now the scale of that has changed. There's a little bit of a difficulty here. It's going to be with that font size. Let's see. It's still not making it any better. But what would be a good idea here when doing this is look at the extent of this. Well, actually, we already have it here in MATLAB. 400 to negative 400. Well, we want to make both of those that, right? So right click and go to axis properties and go set this to negative 400 and this to 400. And then the major units, I believe, are by 100s. Boom. And then do it for the other one too. So that was this inner one. Now do this for this outer one. I know you can't see it very well, but it should show up on yours pretty easily. So we'll do the start point at negative 400 again. The end point at 400. And the major units 100. Boom. Now we can right click somewhere in here and go copy clipboard, which seems weird. It should be copy to clipboard, but boom. And we can put it into here. Yeah, you see, here's the issue. You can't see those values very easily. But we want to make this comparison right here. So here is I guess I decided to make the SolidWorks down below, but you could do the above it or below it, and to make these comparisons. And then maybe we want to try to make the MATLAB kind of about the same size, right? So I can just kind of go like this right here. Look at it. Oh, it just expanded itself. And all right, so here we can go the same type of thing we did before with the MATLAB. We go edit and then copy figure and bring it back up right to there. Yeah, this is messed up with the time with the font size, and I don't have really any control over it. I could keep monkeying. We would do the same thing, by the way, with the acceleration. I won't do that one. You could do it yourself. It's the same process. But here is another alternative, right? So when I wrote this, yeah, I did include these lines right here that are grayed out or that are commented out. So I can uncomment them. By the way, it might cause a problem for some of these things down below, right? So because I messed with the data a little bit in order to get it to come out, right? So and I think I'm only doing this. Let me see. Let me undo what I just did because I can't remember how much. Okay, I just did, and this is only for the velocity. So you would have to adapt this for the acceleration too. But if you wanted to get this data out of MATLAB and put it into Excel, this is how you do it right here. And this, so what I've done is I created this line VP, just something I'm calling it. So uncomment here. And so I put this string together and then I export that VP right here into a file named this. Let's go to, right? And I think everything down here is going to get messed up by what I've just done. So I'm going to comment it out so I won't get the thing. And I'm pretty sure, yeah, I've run this before and it's made this file. So it doesn't like to overwrite files. Oh, look, I've done it right. I gave it a 2 and a 3. So there's going to be 4. You can see the files in the left. I have demonstrated this right here. So I think this will work. And so I'll run it. And that gave me, I don't know, I thought I got rid of the, oh no, I guess the plotting was up above it. Yeah, so the other plotting didn't get done. But it should have created, yeah, MATLAB 4, right? So I could, well, let me open it from there. I guess so. It's kind of weird. I don't like how that's opening. Okay, well, I'm going to open it up in Excel. Excuse me. So I got to find it first. I think it's in this. So, well, let me see. Where am I? I can see my folder. Oh, MATLAB examples. All right. So under MATLAB examples, and there you go. So this is a weird looking icon. So it's probably not an XLSX. Is that right? Yeah, and it's in some kind of compatibility mode, right? But at the top, this is time. These are to the positions of point CC, and there's the X velocity. Here's the Y velocity. Now you could also come over to here and export this to spreadsheet. Whoops. Add method of workbooks. Okay, so what might have happened, yes, it's true. I had, that workbook is open right now, so I am going to close it. I think it wanted to add it to there. I think that's why that just failed. Let's see if this works. Yeah. All right, it's always weird, it kind of does it in the background there. All right, so there are your exported plots. I wouldn't use these. By the way, something I want to bring up. I really hate a few things on Excel plots like this right here. There's no reason to use their title. There's no reason to have horizontal bars right there. And there's absolutely no reason to ever use markers on lines that are not experimental data. If you have experimental data, use a marker. Otherwise, tame that fuzzy caterpillar and turn them off. Turn off the markers. All we need to see is the line. Because the markers don't do anything. They just get in the way. And that doesn't need to be to the right-hand side. Well, anyway, we don't have to fix this because we're about to make our own. But anyway. And you could make a new spreadsheet, if you want to just adapt this spreadsheet, I'll probably just copy the data from the other spreadsheet into here. But other things I will say that I feel strongly about is the number of decimal places of this is ridiculous. So I would get, and also this doesn't need to be in scientific notation, right? That's just what the default came out to. It would make a lot more sense if that was just a number. And we don't need even close to that many we don't need any decimal places right there, right? And honestly, we want to make this scale the same thing as the other one. So there you go, boom. The other graphs. Well, I guess we have. How come it won't let me go to this one? There you go. And we can get a better labels. But anyway, let's go. That's just if you wanted to use that. Instead, let's use this table over here. So let's go. That's this one right up here is. I'm going to go ahead and give my own labels inside of here. Here's going to go time. This is going to be MATLAB. Is that right? No. This is SolidWorks. We might want to go SW instead of SolidWorks VX. Maybe that's good. Whoop. SolidWorks VY. And there you go. I'll also call that time. I guess I can copy the whole thing. Doesn't matter. ML, MATLAB, or it's not that long of a word. It's shorter than SolidWorks. CCX. CCY. We're not going to use it, but then you go. This is how lazy I am. I'm copying that over. We go VX and VY. I say a little itty bitty second then. Okay, so we just copy everything here. I can scroll down and then hit Control, hit Shift. I think just Shift. I think Shift. Boom. Okay. And copy. So I didn't have to hold it down the entire time I was running down there. And I think the increments are going to be different. So, oh yeah, a lot different, right? Like you could take a look and see how long. Yep. So I can just go ahead. I'm going to leave that in here. And you don't have to do this, by the way. This is, I should have said that right from the beginning. You don't have to do this, but you can. Oops. You could, if you needed to. Maybe I should have made that really, really clear earlier. Do insert, and I don't like having that separate page of graphs. I like to put the graphs right here on the thing. But we go to these graphs, here's a scatter chart. And once again, we're not going to use those. We're not going to use that one for sure. I hate that one. We're really not going to use that one. We're going to use this one. It gives it smooths it out a little bit, but it makes those things. And there's a lot of stuff we have to change on this. Let's wait to do that until, I don't know, in a minute. All right, so I have to, a lot of times when I want to bring this graph back up to the top, I hit Control X, then I move up to the top, and then I hit Control V. So I don't have to drag it all the way through. Yeah, I will now, I'm going to add the other data to it. So I'm going to go select data. I right clicked in the back field, select data. I go add, and the series name. Let's see, the series name, this first series name I'm going to pick as MATLAB, that one, right? So MATLAB VX. I'm going to go, my X is going to be here. And I want to know if I can I just go like what I did a minute ago? I think I can. come all the way down and go boom to there? Yes. All right. If you could see these, I know it's going to be really small, but you can actually, a shortcut I can show you is to highlight all of that we just did. All right, so now we're going to go, all right, and he's going to be, oh no, okay, so I just messed up. Sorry, let me edit the thing. All right, I forgot to do the y value. All right, so so that's what they're calling x was time, right? I went all the way down with time. The one I want to do, I'm going to use the h column here, and so instead of doing that whole thing again and dragging it, I'm going to go Control V, and where we have an e in here, I don't know if you could see it. I'm going to put an h. Where I had an e in here, I can put an h. I think you got it, right? You could actually see it. All right, it's on the graph right now. It's really it's gray and it's off by a little bit. I got to think my way through why that's why it's off like that. I think it might be the direction of rotation. I should check that out and try it out, but I don't have the time during this video. We're going to add another one here, and this time we're going to make the y. Let's put the y in there. So there's the series name. It's going to appear in the box. We'll fix the other one in a second. It's the same x, right? So I could just go ahead and paste because I had already highlighted that one before. I don't have to drag. And then I could also paste on top of that. And this time it's going to be where it says E, it should be an I. So you carefully put that in there. I. And that should give me, yeah, you can see they're on top of each other. And as I mentioned, it looks like the bumps are in the wrong spot. Let's fix the series 1 right here. I'm going to edit that, and I'm going to change the name of this data. This is going to be SolidWorks VX. Okay, and then I'm going to click this one, and I'm going to edit that and make this SolidWorks VY. Boom, and that should be done. All right, now we have a lot of things to fix on this awful graph. First off, chart title. You can put the chart title on yourself. You don't need their chart title. There's no reason to have grid lines. The only time you need grid lines if the purpose of the graph that you're making, you want people to pick numbers off of it. But we don't need people to pick numbers off it. We don't need the grid lines, in my opinion. We don't want to go from 0 to 7. We only need to go 0 to 6. So I'm randomly looking at things and not being very systematic. So I selected that X label, and I am going to make it to 6 right here. Boom. So over in the axis properties is over here, and I'll just go to someplace else, and it should, yes. Okay, so we mixed the thing up. While I have that highlighted, there's no reason to have that many decimal places. So I'm going to go number, and we don't need any decimal places, right? So I just have 0, 1, 2, 3, 4, 5, 6. The decimal places serve no purpose. While we're talking about scales, let's go back over to this one. You can see, just as I had mentioned before, this doesn't need to have that. It doesn't need to be in scientific notation, and it doesn't need that many zeros. And we already saw that we could actually change the range to negative 400 to 400. So right here, let's change that range. So we'll see. Okay, so it's being a little weird. It does this to me. I have to go get out of it and go back in. It wouldn't let me select that for some reason. See, I'm only going to put select 400, 400, and then here go to 400. All right. And now I go to the number and change it to just number. And number decimal place is 0. There you go. Some other things have changed. This is not the terrible place to put this, but that's going to be in the way of my label of my thing of my label for this right here. Right. It's not, this is. I don't think there's any perfect way to put that label where it doesn't seem awkward, but we can at least move the legend over to a spot that doesn't like take up real valuable real estate. We're gonna pick a difference in colors in a second because these colors don't really stand out. But I'm gonna move on to the axes. All right, the labels. I don't know why they don't default to have giving you labels, but they should. So up here under the chart tools, under design, you're going to add a chart element over on the left, and you want to add the primary, and then go ahead and put it do the same thing again. Get the primary horizontal and the primary vertical. This has the boring label of time. Always give you units, and in many cases, I will also put what the variable you associate that with. But always put the units after that. I always use brackets. I've seen that as a commonly used thing. You could write out seconds in this case. You could just put S. Everybody knows what you mean. For this title right here, you might want to. You could write just velocity. Let's see. VELOCITY. And you could, if you want to, of point P, or you could just make it velocity. And then make sure you're clear. These are millimeters per second. All right. And finally, I think it'd be nice to mix this up a bit. You could have, all right, so one strategy here, we have this as blue, right? Blue looks good. I don't know why sometimes it'll pick this is the entire thing. Okay, it has picked it. So with the formatting thing up, if you don't have it up already, remember you can go right click and format data series right there. That'll do. Here's the paint bucket will be the line. It could be the line style. Maybe want a darker blue. Maybe make it thicker, make it thinner, what have you. But let's stick with that one with blue. Let's have this one blue as well. We can make it the same blue, slightly different blue. Slightly different blue. And to make it stand out from the other one, let's make this one dashed. Right? So when looking at this, your eye gets drawn to it, and you can see what the differences are between the other one. Now, if you got blue, you might as have one as red. And let's see, let's make sure we're picking the right one here. I think, yeah, this is the SolidWorks one is up there top. So let's make that I think orange looks terrible. Let's go to the darker red. That looks better, I think. And now with this other one, we'll do the same thing. Maybe we'll use slightly different red. It doesn't matter, but what will make it stand out is that you're going to make it dashed. Right there, right? So you can kind of tell from this. You could maybe pick other colors as well, but it gives you the opportunity to see that this thing, this thing has sort of this upside down nature to it, where this magnitude is less than that one, but it's greater than that one right there. So I think it might be running backwards, and I should really rerun it again. But anyway, what we do here now is to take this and put it in. So instead of what we have right here, where we have two separate graphs, we would make a new graph and put him in. And this is not an image. This is actually has a bit of a link to the thing that we're looking at. So we could stretch this. It isn't, and it'll deform and in a way that's going to be useful to us. Actually, I kind of wish I put little ticks. It doesn't show. It's not showing the ticks right there. So that's a little pet peeve of mine as well. It's like we should show. Where are they at? I got the line here. I think it's under this one. Access. Oh, there are ticks. Tick marks options. For the major ones, let's have it. I'll have it cross. Does it show it? There they go. They showed the cross. And then this one too didn't have the tick marks. Oh, went to the wrong spot. There you go. Onto here, tick marks, cross. All right. Looks better. See, where I mentioned that this is not an image that you're pasting in here. It's actually, linked to the Excel file, and that's an important thing to note, that you should probably have them at least available nearby. I don't think it's embedded, but I actually don't know, to tell you the truth, to be quite honest. Now, the text might be a little small on this, and I think, although it doesn't look all that great, I think this text actually looks pretty decent. But I think I would prefer most of the time to have the same font, regardless of, within a document. Not to change fonts, multiple fonts doesn't seem very professional. Now the font, I think what the font right now is only a 10. That's like almost too big right there. And by the way, that this one of the things fell off the legend. So 14, 12 looks decent, right? And you can see everything. Yeah. So that looks like for a pretty good graph. What you can do when you have this type of thing from Excel, so one of the advantages is you could talk your way through. So when you go to animations and you go appear, right? Now that'll just make the whole thing disappear. But like instead, if you come up to here and if you go to animation pane at the top, I think effect options, timing, chart as one object by series. Boom. All right, so when you go to do a presentation, by the way, this always drives me nuts. I watch people start up a presentation and they go and they try to find the thing up here. It's this little guy right here. It looks like a little easel. It says slideshow. When you go, that's one click, the first click, and here's like, so you could talk your way through this piece, right? And people can have a little discussion. What's interesting here is, something went wrong, and it's not showing the dashed line. That's an interesting little quirk, huh? Why did it do that? I don't know. So you might want to pick better colors to see those out, to make the color difference, because it's not revealing itself as dashed lines. You can, by the way, pick this right here and right click and go format data series, and this other thing will come up over here. And when you go to this paint, you can change it right here. Let's see what happens. I mean it looks correct right now, but I bet if you tell it, and then it might make a difference. Nope, didn't. All right. Anyway, this video's gone too long. I hope this was what was being asked when they asked me when a student asked me to make a video on some of the stuff that we covered on Thursday. And 44 minutes. Dang, that's a long time.